Hello guys, welcome to today's class. So today we'll be looking at differentiation from first principle. Differentiation from first principle. So this technique is adopted from our previous class, finding the gradient function and the derivative of a function. So but today we'll be looking at differentiation from first principle. So for example, if you are asked to find the derivative of f of x equals to x squared from first principle, solution. So we say that f of x is equal to what? X squared. Now we are asked to find the derivative of x squared, of f of x equals to x squared, or to differentiate f x raised to power 2 x squared. So now, what you will do, wherever you see x, you put what? Plus change in x. Wherever you see x, you put plus change in x. So we say we have f of x, there's x here, so add plus what? Change in x equals to what? X, there's x here, so put what? Plus what? Change in x. Remember the square. So now the next thing to do, okay, here we still have what? X plus change in x equal to, if you expand this, you have x plus change in x times x plus what? Change in x. So expand this, remove the bracket. So here we still have, if f of x plus what? F of x plus change in x equal to x times x gives you what? X squared plus x times change in x gives you what? X change in x. Change in x times x gives you what? Plus x change in x. Then change in x times change in x gives what? Plus what? Change in x square. So we still have x plus change in x at the left hand side, x square. Now x change in x plus x change in x will give you what? Plus 2x change in x. So yeah, we have change in x square plus what? Change in x square. Now the next thing to do to eliminate this x square, we say minus f of x from both sides of the equation. Minus f of x. So here we say f x plus what? Change in x minus what? F of x equal to what? Remember, f of x equals to, in the right hand side means what? X square. So we say x square plus 2x change in x plus change in x square minus x square. So this will cancel this. We are left with f of x plus change in x minus f of x equal to 2x change in x plus change in x square. So now we divide both sides by what? Change in x. The next thing to do now is to divide both sides by change in x. So we have f of x plus change in x minus f of x equals to 2x change in x plus what? Change in x square divided by what? Change in x. Here we have what? Change in what? X. So now change in x can cancel one change in x here, can cancel change in x here. So we are left with what? We are left with f of x plus what? Change in x minus f of x over change in x is equal to 2x So remember, change in x cancel one, change x. Say you are left with 2x here plus there's remaining what? One change in x here. Change in x. Now we take the limit when change in x approaches 0. So you can say the limit when change in x approaches 0, f of x plus change in x minus f of x change in x equal to what? 2x plus change in x. Remember, when change in x approaches 0, when change in x approaches what? 0. So we have lim change in x approaches 0, f of x plus change in x minus f of x over change in x equal to. So since there is no change in x here, so we have 2x. And if you replace change in x equal to 0 in this side, so you have what? Plus what? 0. So we can say that the derivative of f of x can say the limit when change in x approaches 0, f of x plus change in x minus f of x over change in x is equal to 2x. So this means that the derivative of f of x is equal to what? 2x. The derivative of f of x is equal to what? 2x. So if you differentiate this using first principle method, differentiate f of x equals to x, or the differentiate x square, it will give you what? 2x. So on our next class to still talk on different method on differentiation, we'll talk about general method also. Okay guys, let's try this question. The question says find the derivative of y equals to x cubed from first principle. This thing is still the same thing as f of x equal to x cubed. So you're asked to find this derivative of x cubed. So now remember, I always say that wherever you see x, solving how to find derivative using first principle, whenever you see x, you add plus what? Change in x. If it's in the case of y, you can add plus what? Change in y. So we say that here we have what? F of x plus what? Change in x is equal to x plus what? Change in x cube. Now you have f of x plus what? Change in x is equal to, so you need to expand this. This is the same thing as what? X plus change in x times x plus change in x times x plus what? Change in what? X. Now let's work on this right hand side. Let's expand this. So we know that if you expand this and this, you have what? You have x squared plus 2x change in x plus change in x squared. So if you expand this too, you have this, and this is can still multiply with the third, then which is x plus what? Change in x. So now if you multiply x times x gives you what? X cubed. X times 2x change in x gives you what? Plus 2x squared change in x. X times change in x squared gives you what? Plus x change in x squared. Change in x times x squared gives you what? Plus x squared change in x. Change in x times 2x change in x gives you what? Plus 2x change in x squared. Change in x times change in x squared gives you a plus change in x cube. Now this is equal to, we have x cube. So we can add 2x squared change in x with x squared changing x. So we have what? Plus what? 3x squared changing x. So we can add x changing x squared plus 2x changing x to give you what? Plus 3x changing x squared. Now we know that you can add, okay, there's nothing to add again. So we have plus what? Changing x cubed. So you use this to replace this. Use this to replace what? This. So we can say that f of s plus change in x is equal to x cubed plus 3x squared change in x plus 3x change in x squared plus change in x cubed. So now the next thing to do is to minus f of x from both sides. So we have f of x plus change in x minus f of x equal to, we know that f of x in the right hand side is equal to x cubed. So we can say that x cubed plus 3x square change in x plus 3x change in x square plus change in x cube, then minus x cube. So this can cancel out this. This x cube can cancel out, minus x cube can cancel out x cube. So you are left with f of x plus change in x minus f of x is equal to 3x square change in x plus 3x change in x square plus change in x cube. So now remember, the next thing to do is what? Divide both sides by what? Change in x. So we have f of x plus change in x minus f of x divided by what? Change in what? X equal to 3x cube change in x over change in x plus 3x change in x square divided by what? Change in x plus what? Change in x cube divided by what? Change in what? X. So change in x can cancel change in x here. Change in x can cancel one change in x here. So remaining one change in x, which is change in x. Change in x can cancel one. Remaining what? Two what? Change in remaining what? Change in x what? Square. So we can say that f of x plus change in x minus f of x divided by change in x is equal to 3x square plus 3x change in x plus change in x square. The next thing to do is what? Take limit when change in x approaches what? 0. So we can say the limit when change in x approaches 0, f of x plus change in x minus f of x divided by change in x is equal to 3x square plus 3x change in x. Remember, when change in x approaches 0. When change in x approaches 0. Plus change in x square when change in x approaches 0. So wherever we see change in x, we replace it with what? 0. So we have that the limit when change in x approaches 0, f of x plus change in x f of x plus change in x minus f of x divided by change in x is equal to 3x squared. If you put 0 here, everything here turns to okay, plus 0 turns to 0. If you put 0 here, everything here plus turns to 0. So the limit when change in x approaches 0, f of x plus change in x minus f of x divided by change in x is equal to 3x what square. So we can say therefore f prime, which is the derivative of the derivative of f of x is equal to what 3x square. We can say that derivative of f of x equal to x cube is equal to what 3 what x square. So this is the answer. This is how to find derivative from what first principle. Remember, in our next class we're going to talk on how to find derivative using what the formula method before we go to other methods like product rule, quotient rule, sum rule, function of a function, etc.